Technology is reframing the way we live. Many important decisions, usually made by humans, are now being made by computers. Regarding the legal system, things couldn't be different. My name is Ferrari. I'm a Brazilian federal judge and a researcher in the field of law and technology, and in this short video, I'm addressing the risks and possibilities of algorithmic decision-making in the judiciary. We see a growing discussion about the new possibilities AI brings to judicial decision-making. As highlighted by Professor Lawrence Solon, in legal systems, AI might be adopted to, first, provide non-binding recommendation to judges regarding, for example, the precedents they might adopt in their decision or even drafting decisions. Second, provide judgments that must be followed unless the human judge provides a legally sufficient reason to override the judgment. And third, and the most frightening possibility for many, replace human judges in some cases. Although this seems dystopic, it's good to remember that Estonia is already developing a robot judge to decide small claims. And if we think about it, it kind of makes sense. I mean, we're talking about lawsuits that involve not civil or political, but only proprietary rights, and of small amount, and usually lawsuits that repeat themselves a lot. So we could argue that there is not much room or need for human creativity, and it's not extremely dangerous if occasionally these lawsuits are ruled in the wrong way. After all, it also happens when we're talking about human decision-making. Robot judges can definitely help us foster some of the rule of law values such as accessibility, efficiency, consistency, and deal with the huge backlog that in many countries has increased with the pandemics. But before we decide by this course of action, what should be our concerns, our points of attention? Before answering that question directly, we should step back and understand how AI operates. And we start by a definition of algorithm. The one I prefer is that of Pedro Domingos. Algorithm is a sequence of instructions that tells a computer what it should do. Simple and direct. And then we can split algorithms into two different categories. The first, programming algorithms, also called good old-fashioned AI. In their case, the programmer defines all the path that the information, the input, will follow until the end of the processing when the result, the output, is presented. Please notice that although intelligent decisions are made in this case, the software has not properly learned anything by himself. He was taught what he should do. The situation is completely different from that of the non-programming algorithms, the algorithms that adopt machine learning techniques. When I talk about them in my classes, I usually refer to an idea Alan Turing presented in a paper written in the 50s. He questioned, why, instead of delivering all the available information to a computer, don't we program the computer like a brain of a child with autonomous ability to learn? It's basically what non-programming algorithms or machine learning algorithms do. They learn based on the data they're fed with. Due to that learning activity, they create their own programming. We need to pay attention to this point. Machine learning algorithms learn finding hidden patterns on the data they're fed with. These patterns are found after several correlations in many layers. As they operate in complex ways, the mere observation of the result of their operation, the output, usually does not allow us to understand the internal path that converted the inputs into the results presented. Even if we're talking about an open source algorithm, looking at their code usually does not solve our problem. The code in machine learning algorithms does not bring the rule that governs the decision, but only the instructions that command their learning activity. In fact, the rule of decision emerges from the interaction of their operation, their learning activity, and the massive amount of data they're fed with. Therefore, there is a gap between the activity of the programmer and the behavior of the species of algorithm. And that is why even programmers would not be able to fully explain the internal path towards the final decision. The first concern regarding AI decision-making is therefore the opacity that there is inherent to this kind of algorithm. They are opaque in the sense that the recipient of the output of the algorithm rarely has any concrete sense of how or why they have arrived at a particular decision from the inputs. The problem of opacity is a pressing issue, but is already being addressed by programmers who are developing an emerging field called explainable AI. It aims to address how black box decisions of AI systems are made, seeking to understand the models and the steps involved in AI decision-making. The second concern is even more problematic, as well as difficult to solve: bias. Once algorithms learn based on the data they're fed with, and considering this data is produced in the midst of the biased societies we live in, it is natural that they also learn and thus replicate this biased pattern, therefore targeting historically vulnerable groups such as women or Black people. Bias is usually a silent threat and a very hard one to identify. Even when we find discriminatory patterns on data, the way forward is a challenge. Should we message data to make things better? And if yes, how? This is an ongoing discussion that should definitely involve not only legal operators and programmers, but the private sector, policy designers, legislators, and the community. But this talk is not to say that we have a bad scenario when adopting AI to assist decision-making in law. In fact, we have new opportunities to deal with the opacity and implicit or explicit biases of human decision makers that can be much harder to find and root out than computational ones. Therefore, in the scenario of ongoing change and looking at the future of the judiciary, the fundamental question does not seem to be whether we're integrating technology into the judiciary, but where and how we're doing so, and the safeguards that we must take. In which situations is it safe to use AI to assist decision-making or even substitute judges, strengthening, therefore, the values of accessibility, efficiency, consistency? How can we calibrate machine learning algorithms to improve decision-making, reduce human bias, and hence advance faster towards a more inclusive society? In which cases, only a human decision, even if mistaken, would be acceptable? The answer to these questions might affect us all. Everyone's voice is important. I call you to use yours. Thank you.